Hello, I'm going to present our work on the continuous deployment of Trustworthy Smart IoT system, which has been published at ECMFA 2020 and is a work that has been conducted in the context of the ENACT Edge 2020 project. This work in particular is a result of a collaboration between SINTEF and Technalia. So let's discuss first about the type of systems that we are considering here. We are considering smart IoT systems. So smart IoT systems are basically IoT systems that not only consider sensors, but also actuators. And they can include some closed loop from sensing to actuation, meaning that they can gather data from sensor, upload the data to some, for instance, gateways, and the gateways can trigger an action on the environment via an actuator. And this closed loop, they can be distributed all across the IoT edge and cloud infrastructure. In addition, as classical IoT system, smart IoT system operate in the unpredictable physical world, meaning that it is very difficult for developers to anticipate at design time all the situations that the system will face during operation. So all these properties, and in particular the fact that the system they involve the actuators, they call for trustworthiness. And it is important to ensure the trustworthiness of this smart IoT system. In this work, we focus in particular on one of the properties of trustworthiness, which is security. So, because the situation that in which the system operates may change frequently, because new trustworthiness threats may appear over the time, it is important to support the continuous evolution of smart IoT system. And as part of this, we need to support the continuous deployment of smart IoT systems. So in the recent year, there has been a lot of effort on supporting the deployment of software systems and in particular of cloud-based systems. But we can see that there are very little tools that have been designed and thought from the very beginning for supporting the deployment over the whole IoT edge and cloud spaces. And in particular, there is very little support for supporting the deployment over devices which does not necessarily have direct access to internet. We also see that there is a lack of support for trustworthiness in these tools, and in particular for security. So to try to address these challenges, we propose Genesis. Genesis is a tool that is composed of two main components. First, a modeling environment with a domain-specific modeling language to model the provisioning and deployment of secure smart IoT system. And second, a model at runtime environment for enacting the provisioning, deployment, and adaptation of these systems. So you can find more details about the Genesis modeling language in the paper, but here in short about the core concept of Genesis. So Genesis inspired from component-based systems, and so a deployment model is represented as an assembly of components, so component and links in between components. These components and links, they can be attached with properties and what we call resources, which are used to manage the lifecycle of the components and links. Also, we can specify security and privacy capabilities and requirements as part of your deployment model. So now I'm going to show you a quick demo of Genesis. So this is the Genesis graphical user interface, and as you see, I have already loaded a deployment model. This is a deployment model of a smart IoT system for a smart building. More details about this example can be found in the paper. So this smart building is basically composed of three main gateways. A first gateway, which is called the building control. This is basically a gateway which helps us interacting with the PLC in the context of the real building. For this demo, I used a simulator of a smart building instead of the real building, which is called Omayo. So this gateway hosts in particular a broker that helps us interacting with Omayo in this very demo. Then we have a second gateway, which is called here IoT Smart Space, which helps us interacting with sensors, actuators, and in particular with two Arduinos that does not have direct access to internet. So they have access via the gateway and they are physically connected to the gateway. And finally, a third gateway called App Server, where we are going to deploy some smart application. In the first step, we are going to deploy a user comfort application. It is important to note that the communication between the app server and the IoT space and the devices is made via an IoT platform called Small, which is based on Sophia. So let's start our deployment. So we initiate the deployment here, and we can see that the color scheme represents the status of the deployment. The status about the deployment are also reflected in the model at runtime engine of Genesis. So here we first use the deployment agent to deploy software on the two Arduinos. So deployment agents are basically generated by Genesis, and they are deployed on the gateway which is physically connected to the Arduinos. They typically consist, this deployment agent, of a set of predefined components for compilation, configuration, deployment, and communication back and forth with Genesis runtime environment. More details about the deployment agent can be found in the paper. So we can see here the deployment agent that has been generated by Genesis. So this is the first one for the first Arduino, which deploys some Arduino code directly. So build and deploy some Arduino code directly. And then we can see the deployment agent generated for the second Arduino, which is consuming some SingML code, compiling SingML toward Arduino and deploying the Arduino code. So once all the software that needs to be deployed by deployment agent are deployed, we deploy the rest of the other software component of the smart IoT system. So here we go. So we can see the deployment is going on, and we see that in the end all components are turning into green, meaning they are all running. So at the second stage, we want to add a new application in our smart IoT system, and this application wants to control the blinds in the smart building. So in order for this application to actually be able to control the blind, we need to update our security policy, and to do so we can do it easily by just using Genesis and tuning a property in the Genesis deployment model. So this is because we have introduced a set of specific component for security by design, specific Genesis security component, and which are integrated and for to be used by IoT platforms, and in particular demonstrated here with a small IoT platform. So some of the properties that are supported by this specific security component are authentication, confidentiality, integrity, and non-repudiation. So let's see now the deployment of our new smart building and smart IoT system. So we load a new deployment which is an extension of this one, and we deploy this new deployment model. So only the difference is computed, and only the part that needs to be deployed will be deployed. So these parts are a new application called energy efficiency, and the components to communicate with each other via the small platform. And in particular, we are tuning here the security policy. This component will be deployed, and we can see here we can connect to to the small platform, and we can actually see the messages that are being sent to the small platform. And one of the things we can see here is that there is actually already an application or software somewhere which is trying to control the blind. But because they are not part of our security policy, all these messages and orders are just discarded. So now let's open our application. So let's see first the properties that we use to define the security policy. Here it is. And now let's open our application, and let's try to control the blind. So here you can see on the very top right Home.io, and we triggered the order to open the blind, and we see that Small it receives this message, and this message has been approved. So if you want to see more detail about our support for the continuous deployment and security mechanisms, please refer to our paper to ECMFA 2020. Thank you very much for your attention.